Hello again, SOTA fans. Well, it's been quite a while since I've posted a video, but the weather's not too good today, so I thought I wanted to take a look at something that's very relevant to SOTA these days. What with so many different rigs needing so many different voltages, these DC-DC step-down regulators are becoming increasingly popular, but some questions hang about how good are they? Do they produce noise in the received signal? And in fact, do they produce spurs on the output? Yeah, because of course they rely on high frequency switching. I think most of them about 100 kilohertz, depending on the chip. Yeah, some people say, you could get spurs on your outputs. Well, I've never had any problem with noise on my inputs, no matter what radio I've used. Here we've got my mountain topper, we've got the QCX to look at today, and the KX2. But of course, spurs on the output's not an easy thing to measure if you don't have a spectrum analyzer. I recently got this tiny spectrum analyzer, tiny SA. They're not very expensive, about €60. I'll put a link in the description. Most people have one now. So I thought it'd be great to actually check and see if there are any spurs in the output of these DC-DC regulators. I've got my Sanford watt meter there, which has a minus 36 dB sample output. So built-in attenuator, that's very useful. But before we do, of course, it's interesting to have a talk about why are these DC regulators so good for SOTA. Well, of course, different rigs need a different amount of voltage, and of course there are so many different batteries. It's not always easy getting exactly the right voltage. Here I've got 4 lithium-ion cells, fully charged, that's 16.4 volts. It's too much for most rigs. It might go okay in the QCX, which is like 16 volts, but it would definitely kill our poor little mountain topper here, which wants no more than 12 volts. And it's a little bit too much for the KX2. Once you're over 15 volts, it will switch off and go over volts. That likes about 14.5 for the 12 watts maximum output. So yeah, if we can simply control our voltage by turning a screw, here I've got the output voltage set to 11.9. If I want to change it, I just turn that screw there and I can turn it up or down. So very useful, like I say, providing they're quiet and they don't produce any noise. So we're going to have a look at that today. And I've got a variety of rigs, and I've also got a lithium iron phosphate battery there. And the other great advantage of being able to use these loose cells is, of course, when you go on holiday, because some airports will get a bit funny if you turn up with a lithium iron phosphate in your bag. They don't always like that because, of course, they are a bit dangerous. It depends what airport you go to. It is allowed. You are allowed to fly with these in the international regulations, and but some airports still can be a bit funny about it. So what you can do is you can buy one of these power packs, and you have to put your own cells in this power pack. Okay, you see it will take 4, and once they're in and closed, if you go through airport security with that, the people will probably not think to open it because most power packs don't open. So it doesn't occur to airport security that you can actually open this and take the cells out of it. It just looks like a bog standard power pack, and these are very cheap as well. They don't charge your cells up particularly quickly. You'll need to put it straight on charge when you get back from your activation, and it should be okay for the day after. But it is very convenient. It means you don't have to take your specialized charging equipment for this battery, so it's less to carry. So they have a huge amount of convenience, these DC-DC regulators. But like I say, some questions do linger over how good they are and whether they produce any harmonic spurs on the output. So what we're going to do is we're going to switch over and have a look at a few different rigs and see what happens. You can see I've got my tiny SA plugged into my computer, so we can see what's going on the big screen. I've got my document cam here, and first we're going to have a look at the KX2 and see what happens there. So let's turn it on first, and as you can see, I've got it plugged in to my lithium iron phosphate to begin with. and we're going to go at 7 watts, I believe, 7 megahertz, and I've got the power. I'm trying to keep the power the same between all devices. We're at 4 watts there, so I'm going to just quickly transmit and take a snapshot. So there we go, we're transmitting fine. Let's take a scan. Okay, and turn it off. And here we can see pretty much what you would expect. What have we got here? So here's the 55 dB mark. And as you can see, there's absolutely nothing above 55 dB. These, I think, are your normal harmonic spurs in diameter bands. As we would expect, we've got 2 spurs here, 9.2, and what's that one? About 8.4 megahertz. But it doesn't. These don't look particularly like the 100 kilohertz harmonic, and certainly we can see there's absolutely nothing above 50 dBs, which is your limit for the amateur bands. So it's very clean there, and as you would expect from a lithium iron phosphate battery. Okay, so we're going to unplug that now, turn the KX2 off, unplug it, get rid of that. Let's now put our DC step down in, plug it in, turn on the radio. Okay, same frequency, 7.030. Gonna transmit and scan. There we go. And just while we're just out of interest, you can see I'm doing 3,000 points per scan. Receive bandwidth, don't have these on auto. Always set your receive bandwidth to very low, 3 kilohertz. Attenuation, I've no attenuation because the attenuation is coming from my Sanford watt meter. Yeah, and that's all really you need to do. And as we can see, again, absolutely nothing. We've got these same ones here, these same spurs at 9 and 8.4. So I don't think that's anything to do with power supply. I think there's something different. I wouldn't like to say what. And as we can see, still absolutely nothing above 50 dBs. Nothing to worry about there in that power output. So that's the KX2, but some people might say, well, the KX2's got all these kind of bandpass filtering. It's a very heavily engineered rig, very advanced. You wouldn't expect that to have much on its output. More simpler rigs are going to produce spurs. So let's check that. Let's have a look first at, I think, the mountain topper. So I'm going to unplug this and get rid of my KX2. No, actually, we're not going to have a look at the mountain topper. We're going to have a look at the QCX because it means I don't have to change the patch lead. So goodbye KX2. Here's my 80 meters. This is a QCX for 80 meters. I'm going to quickly plug the power in there. And I'm not going to use that first. We're going to have a look at the LiFePo, the LiFePo. Plug that in. Right, I'm going to have to go into key mode and put it in straight key. Oh. So let's have a look. No. Presets. Unfortunately, you can't see this screen because it's too bright. There's no way I can do that. No, but I can read it. So I'm just in key now. And gonna go to straight key. Okay. I'll just check that this can. Yep, there we go. A good 4.5 watts there. So I'm going to transmit and scan. Oh dear, oh dear, it's frozen. Right, this occasionally happens. My spectrum analyzer sometimes freezes. The patch software isn't absolutely perfect, so I'm just going to turn it back on, turn it off and on again, reconnect it. Here we go, COM5, And the good thing is I don't have to redo all these settings. They'll get transferred automatically as I scan. So let's have a look. It's got to connect here. We're connected. Good. Let's try that again. So transmit and scan. Here we go. Good. Something interesting. Oh, how interesting. It says here we've got minus 25 dB at 7 megahertz. That's not very good. Now I wonder what that is. Because that's a LiFePo, it shouldn't be happening. That should not be there. But I notice what has changed is my points per scan. I want 3,000 points per scan. So center frequency. Let's try this again, just one more time. A bit puzzled by that. This probably suggests that maybe I've done something wrong. Okay, there you go. So everything else is great, but oh dear, we've got a big spike there, minus 25 dB at 7 megahertz. I'm not sure that's the power supply. That could be the filtering on this QCX. So there could be what it does indicate is possibly a problem with the filter stage there. I'll have to have a closer look at that some other time. So let's unplug and plug in our switching power supply, see if anything different happens now. Okay, 3520. Are we still in straight key mode? Yes, we are. Slightly lower output this time because the voltage is a bit lower, but I'm going to transmit and scan. Let's have a look, see what happens. So as you see, we've still got that there. So that, I don't think that's got anything to do with our power supply whatsoever. Everything else is well below 50 dB. In most cases it's below 60 dB. Yeah, this is something else, and I'm going to have to look at this another time and try and figure out what that is, why it should be there. It's odd to think why only on 7 but no other frequencies. Well, okay, that's the QCX. So it doesn't reflect too well on my building. But of course this is the first time I've actually put the QCX on the spectrum analyzer. So it just shows how useful this tiny SA is when you're building. Let's get rid of that now. So I'm going to unplug it here. And we're going to have a last look at the mountain topper. Now, here's the mountain topper. Put that there. And I've got to rearrange my patch leads. So I'm going to be fussing about a bit. I'm going to get this to focus a bit. That's better. So you can see it now. Let's turn it on. Oh, hang on. Just got to plug in here to get this into straight key mode. I've got to hold the paddle closed and turn it on. And we're going to put it on. We're going to turn it on, put it on to 40 first. Turn it on. That's interesting. So, no joy. I wonder what has happened here. I wonder if I've blown my fuse, which I think I have. I've gone and blown the fuse. It's only a 1 amp. There you go. And I drew too much. So, what I've got to do is I'm just going to pause and we're going to come back in a moment. Okay, so I quickly swapped out that fuse. I think I used it with the KX2, which has a much higher current draw. I forgot, even though the power's the same, current draw's much bigger, and it blew that little 1 amp fuse. Luckily I have a spare. Let's plug it in, turn it on. Yes, brilliant. So the mountain topper's on, but I have to put it in straight key mode first, and that means holding in the paddle and turning it on. we're in straight key mode. Let me just check against the watt meter. Yes, there it goes. Good. Right, so let's have a look at the output here. This is just with a normal LiFePo, as you can see. I'm going to get ready here to scan. So we transmit and scan. So there we go. And here you can see we're back on 7. And yeah, nothing over minus 55. A little bit higher on 21, but absolutely as you would expect. Again, we've got a little spur here, about 8.4 and 9. We had that with the KX2. I think these are nothing, absolutely nothing to do with the power supply. And these as well. Yeah, that's pretty clean. So let's turn off. That was our lithium ion. I'm going to put the step down regulator in now. Connect it up. Hold the paddle in, put it in straight key mode, turn it on. Okay, let me just check I'm in straight key. Good, yes. So let's do our last scan here. There we go. As you can see, there's just absolutely no difference at all and no spurs whatsoever in the output there. It's perfectly clean, especially here. I mean, yeah, I see personally absolutely no difference whatsoever. I mean, this is the first time I've really used a spectrum analyzer. I'm no expert, but you know, at first glance, there really seems to be absolutely no difference. Of course, there are different kinds of step-down regulator, so they're not all the same. Some do produce a little bit of noise depending on your frequency, but they're so cheap you can try out a handful, and I'm sure you're going to find something that actually does the job for you. So there you go. Apart from having to open up my QCX and have a look inside that, it's all good news. I can go on using my my step down regulator, confident that I'm not really producing any harmonics at all. So that's all. I hope you found this useful, not just about regulators, but about how to use the Tiny SA with a computer. And I'll see you all next time. Bye for now.